We're using 7 centimeters as our unit, and we're going to make a circle with a radius of 1 unit. I'm going to assume that you can stop this video anytime you want in order to either replay it or take your time doing whatever step you've just looked at. To build the first triangle, which is the 30, 60, 90 triangle, you need first to have a segment that's 1 unit long, and then to draw these half circles with the center at each of the 2 end points of your segment, leaving the radius at 1 unit. Once you've done that, you can connect the dots, basically the intersections of the arcs,
and then draw the diagonal.
With the line segment.
The idea here is that we're creating actually 2 equilateral triangles, and then splitting one of them in half. So let's look at this top one. This is the equilateral triangle that we're going to use. All of the angles are 60 degrees. This is a right angle because it's the diagonal, and that makes the angle at the top 30 degrees and the angle on the right 60 degrees. And we're cutting out the piece, and then we're going to make sure that both sides are labeled with not only the angle measurements, but also the side lengths. We know that the side lengths were 1 of the equilateral triangle, and that means that 1/2 will be the lower length there. And special right triangles, square root of 3 over 2 is the long leg. In order to make the 45, 45, 90 degree triangle, we're going to start by making a line segment that is longer than 1 unit. Then we're going to pick a point and use that to create a 1 unit line segment on this original line segment, the longer one. So that distance from there to there, from A to B, is 1 unit. The next step is to set the compass with a small radius, and then go ahead and create 2 circles, one around A and one around B. The next thing is to set the compass back at 1 unit, but to use the circle that's closer in, right, so that we're actually using something a little less than 1 unit. And we're going to make some arcs. We're going to use as our centers each point where the circles we just drew intersect the line segment. So C, D, E, and F are our centers, and we are drawing arcs, all of which are the same length, a little bit less than 1 unit, so that it looks like this. You can do that on both sides. And the next step is to take a straight edge and connect the intersections of the arcs as segments that will go straight through A and straight through B. Those segments are at right angles to the first line segment. And we're going to extend them here so that we can measure off 1 unit of height for each of those 2 lines. So we set the compass, we put the center of it on A, and then make a little arc up 1 unit away, and do the same thing for B. Now we have right angles, we've got segments, 3 segments that are all 1 unit long, and if we connect the dots at the top, we'll have a square. Now we're going to connect the diagonals. We're going to draw diagonals through the square, and by doing that we create 4 congruent triangles, and we know that the intersection in the center is a right angle, so they are all 4 congruent right triangles. We know that the hypotenuse is 1 because that's the side of our square, and that means legs are square root of 2 over 2. So now what we have are 2 special right triangles, one 45, 45, 90, and the other 30, 60, 90, labeled on both sides, so we can use them to go ahead and make a unit circle. What you do is take the 30, 60, 90 triangle and put the 30 degree part at the center, and then mark it and connect across like that. So and then you do it again. You're using your 30-degree measuring stick to make two 30-degree angles, one right after the other, with the radius being the hypotenuse of your 30, 60, 90 triangle. And then you take the 30, 60, 90 triangle and turn it around so that you're using the 60-degree angle to double check to make sure that it's right. Once you've done that, you can go back, use the 30-degree angle, put the triangle back in the way it was when you first drew it, and mark the distances. This length is 1/2, the radius is 1, and the other side is square root of 3/2. Those measurements are the coordinates of the point where the hypotenuse meets the circle right here. So you have the x-coordinate is square root of 3/2, and the y-coordinate is 1/2, and you can write the coordinates of that point right there. Then if you take the triangle again and use the 60-degree side, you can figure out what the measurements are here as well. You have 1/2 at the bottom and square root of 3/2 at the side, right here. And that tells you that the coordinates of the point where the hypotenuse hits the circle are 1/2, comma, square root of 3/2. Now we just go through, use the triangle, and make 30-degree angles all around the circle. Just fill it in so that we have spokes at 30-degree intervals. Once that's done, we can go back to using our measuring stick here to determine the coordinates of each of the intersecting points. And while we're at it, we can also fill in the degree measurements that we know, just sort of by counting 30 degrees around the circle. We know that if that's 90, that's 120, that's 150, this has to be 180, and we can do it all the way around the circle. When we're done with that, we'll be almost all the way through finishing the unit circle. All we need to do is add the 45-degree angles, and for that we're going to need the other special right triangle. So we'll use the 45, 45, 90-degree triangle to draw in the remaining spokes at 45-degree intervals all around the circle. And as we go, we'll also fill in the measurements of the angles, 45 degrees there, and we'll also put in the coordinates that we now know of the points. It's the square root of 2/2 to the right, and then up the same amount, square root of 2/2. As we go, put in the coordinates, put in the degree measures, finish it up, and we've got ourselves a unit circle. All we have to do now is add the radians and the revolution measurements of each one of those angles. Now before I did that, actually what I would suggest doing is using different colors to draw the diameters that are related to each other. The 45-degree angles that you just did, those could be one color. The X and Y axes could be another color. And then the angles that are 30 degrees away or 60 degrees away from the x-axis can be a third and a fourth color. The advantage of doing this is going around and looking at each color where it connects with the circle. As you do that, you'll notice that the coordinates are the same for each one of those, for example, those 4 points, except that the signs are different. This gives you a real visual understanding of the symmetry of the unit circle. That understanding becomes even stronger as you go around and label the number of revolutions. That's 1/4 of a revolution there at the top, 1/2. By the time you get to the other side of the circle, you've gone halfway around it. And you know that when you get all the way around the circle, you've not only done 1 revolution, but you've gone a distance of 2 pi. It's 2 pi radians at this point. Well, if it's 1 revolution, but 2 pi radians, It means when you go around to each one of these coordinates and you look at how many revolutions it is, you multiply that by 2 pi and you'll know how many radians it is. When you're done, what you wind up with is a unit circle that you built. You may want one that's all printed up and easier to read when you do your studying, but having built one gives you a better understanding of what each one of those lines mean and how each one of those coordinates is found, and that each one of those coordinates is the cosine and the sine of that angle. That's what you need to learn.